Hey everyone, you're welcome to my YouTube channel at SMDexecutive Academy. So in this video, we'll be explaining two concepts. And these concepts are, the first one is the movement of current in a circuit and also the movement of voltage in a circuit. So this is a circuit we'll be using. The circuit is consisting of two resistors in parallel connected to another resistor in series. So these two resistors are in parallel connection with this one in series. So if you look at this diagram very well closely, you will understand that this is the source, that is the cell where 15 volts EMF is being produced alongside a current which is unknown yet. So current must be produced to this parallel connection. So normally, if current is produced on getting to this junction of parallel connection, at this point, your current has to be shared. So you should know that in parallel connection, current is shared, voltage is constant. In series connection, current is the same, voltage is shared across each component. So we'll be calculating the current. Yeah, we can see in this diagram that 1 ampere is the current entry into this 3 ohms resistor. Then the current entering into this 6 ohms resistor is yet to be known. All right, so what do we do to get our 6 current entry into the 6 ohms resistor? One thing we should know is that the voltage that enters into 3 ohms resistor has to be equal to the voltage that will enter into this 6 ohms resistor. So what I will do is that I will say the voltage across 3 ohms resistor is equals to the voltage across the 6 ohms resistor. So if the voltage across the 3 ohms is equals to 6 ohms, then what's the formula to calculate the voltage across that 3 ohms resistor? The voltage has to be current that passes through the 3 ohms resistor multiplied by the resistance of that 3 ohms resistor. Must be equals to the current through that 6 ohms resistor times the resistance of that 6 ohms resistor. So with this, we can easily get our current that enters into this 6 ohms resistor. So with that, we can say that we have current of the 3 ohms resistor times the resistance of that is 3 ohms equals to then the current of this times the resistance of that, which is what, 6. But we are given the current that entered into the 3 ohms resistor, which is what, 1 ampere. So we replace this one by this 1. So that becomes 1 times 3. We have 6i equals to 6i rather. So 1 times 3, we have 3. Then 3 equals to what? 3 equals to 6i. Therefore, we have 6i is equals to 3. Then current through the 6 ohms resistor will be equals to 3 over 6, which tells us that the current through the 6 ohms resistor rather is equals to 0.5 ampere. 0.3.5 amps. 0.5 amps, sorry, please. So as we have 0.5 amps, it means that through this point here, we have 0.5 ampere that entered into the 6 ohms resistor, which means that the current that was coming before entering altogether has to be the current that was coming before sharing here was 1.5. So we say the total current before getting to this junction of this parallel connection equals to the current of the 3 ohms resistor plus current of the 6 ohms resistor, which gives us 1 plus 0.5. Definitely we have, that's 1.5 ampere. If 1.5 ampere entered into these two resistors, then recall I told you that these two resistors are connected in parallel, but eventually also connected in series to this, because these two resistors now will function as one, then in series to this 6 ohms resistor. So in series connection, current is constant. If 1.5 is the total here, then 1.5 will also enter into this 6 ohms resistor. So the current into this 3 ohms resistor is 1 ohm. This is 1 ampere, 0.5 ampere, then 1.5 ampere into this. So if we are to resketch now, we can say that this 3 and 6 ohms resistor, the total resistance, the total effective resistance of these two will be solved in parallel.